Hey folks, so now that we have an understanding of using the binomial probability formula, we're going to look at another method which is a little bit easier, hopefully, and involves tables. So now the only issue with these tables is that there are some restrictions. So specifically, n cannot be greater than 8. So that's the maximum value of n we're going to see on this particular table that's in your textbook. If you look out in the world, there's probably other tables that have larger values of n, but for our purposes, we're only going to use the table that's in the textbook, so only up to 8. And the second one is that the probability p must be listed at the top of the table. So there's only a select number of probabilities that could be used. So we can't just blanketly use any probability we want. So, and we're going to see it in action. I have the table here, so we'll hopefully get you on the right page, so to speak. All right, so we have a few problems that we need to find probabilities for. So we're going to use find the probability of x successes given the probability p of the success on a given trial. So if we have n is equal to 8, x is equal to 2, and p is equal to 0.05. So keep that in mind. So I'm going to put the table right here where you can see it, and it's Appendix A in your textbook. So now for this, we got all these different values of n. So n is equal to 2 and 3 and 4, and all the way down, we got to n equals 8. All right, and then you can see the next column is x, and then you have all these different values of p in between. So what we had was n equals 8, so we want to go all the way down to here, and then we had x is equal to 2. So now we want to go down to x is equal to 2. And then we had p was 0.05. Let me double check. 0.05 is right. So 0.05 is this second column. So we got to make sure we cross-reference these correctly. Got to work our way down. And there it is. So we got 0.051 is going to be that probability. And that is it. That's your probability, and you're done. So no calculations, no real funny business. You're just reading it off your table. So let's do it a few more times just to make sure we got it, and then we can take a look at some of the last questions. So we got n is equal to 5, x is equal to 1, p is 0.70. So n is equal to 5 is right here. We got x was 1, so right here. And now we want 0.7. So 0.7 is right here. So we're going to want to come down, and there it is, 0.028. So probability of 1 is 0.028. And done. So very, very quick with these problems when you're using the table. Now, are there any potential issues with this? Well, let's take a look at the next one. N is equal to 6, x is equal to 5, p is 0.01. Okay, so here's our table. We got n is equal to 6, x is equal to 5, and then probability is 0.01. So that's the very first column. So if we go down to where n is 5, or x is 5, we get a 0 plus. So remember what 0 plus means. 0 plus just means that the probability is very, very small. So it's so small that you can treat it as 0. So mathematically, remember, you can treat that as 0 in those problems. So let's take a look at the next one just to make sure we got it. So n is 7, x is 4, p is 0.05. So n is 7, x is 4, and 0.80. 4, okay, 0.80. So it looks like we're going to be right here. So again, 0.80 is right there. So 0.115. Nice and quick, right? So you're probably saying, can't we just use the table for everything? Please, please, please. Unfortunately, that's not real life. So anyways, let's take a look at a potentially real life problem. So we're going to have to see, why is the table potentially have some issues. This last example is going to really kind of just, or not last, but second to last example is going to kind of highlight why the table has some flaws. So let's just take a look. We have the fast food chain McDonald's has a brand name recognition rate of 95% around the world based on data from Retail Marketing Group. Assuming that we randomly select 5 people, find the following: the probability that exactly 3 of the 5 people recognize McDonald's, and the probability that the number of people who recognize McDonald's is 3 or fewer. Now, looking at our information, our N, X, P, and Q, that's going to help us determine whether or not we have to use the formula or the table. So N in this case is 5 because we're just looking at 5 people. And our probability is 0.95 based on the 95% recognition rate. And so we should be able to use the table for this. Now, remember, for part A, we got X is equal to, in this case, it's exactly 3. So let's see what we get for P. Probability of 3 is going to be equal to, so we want N is equal to 5. All right. X is equal to 3. And then we want 95% recognition, so that's way over here. So let's just make sure I have these right. So let's go down, and it looks like 0.021 should be that probability. Nice and quick. All right, let's do a little bit of, describing of this 3 or fewer before we jump to the last page. So 3 or fewer, what does that actually describe for specific values of X? So 3 or fewer. So that means 3, 2, 1, and 0. So all of those individual cases will contribute to that overall probability. So now let's see what we have on the next page. So you can see we already have the binomial formula done for you. Thank you very much. And so now if we populate the table for the rest of these, we should be able to get our overall probability. So again, we got N is 5. We already found 3, so now we need 2. And we're going to have to go all the way over to 95%, so 0.001. And let's just keep going, looking up. So 0 plus and another 0 plus. So there's some problems potentially. So we got 0 plus, 0 plus. Now remember, we can treat these as 0 when we're using it mathematically. So if we add this up, we do get 0.022. So there's our total probability of 0.022. But if we use all of these decimals and everything else, we can kind of see that it's going to be 0.0226. Now we would round that, if we round that to 3 places, we would get 0.023. So there is a slight discrepancy between the table and the formula. Not a huge deal to worry about overall, but just something to keep in mind. All right, so I'm going to stop the video there, and then we'll pick up this last question in the last video. So see you in a minute.